So on my first day at my very first engineering job, I was just dropped headfirst into this million-line legacy code base.
Oh man, that is rough.
Yeah, I spent like 3 hours just trying to find where a single variable was defined.
It is terrifying when you realize the map you were given,
Yeah.
doesn't match the actual terrain you were standing on.
Exactly. I felt like I needed a pirate's treasure map and, I don't know, a machete just to navigate the folder structure.
That is basically a rite of passage at this point.
Right. Well, today we are looking at how we're solving that problem at scale, not just for human developers, but actually for AI.
Which is such a massive shift in how we work.
It really is. But before we get into all that, if you need help with AI training, automation, software development, or uncovering where AI agents can actually make an impact for your business, check out embersilk.com. Embersilk has you covered.
So our mission for this deep dive is to figure out how AI doesn't get lost in those million-line jungles.
Yeah, we've pulled from technical documentation and engineering blogs about Claude Code to see how it navigates these massive enterprise environments.
So how does an AI look at a sprawling code base differently than, say, older tools?
While older tools mostly rely on something called RAG, retrieval augmented generation.
Right, where they bake your entire code base into a centralized index.
Exactly. But the problem is, at an enterprise scale with hundreds of developers pushing updates constantly.
That index is just instantly out of date.
Oh, totally. You ask the AI a question and it retrieves a module that somebody deleted like 3 days ago.
So a RAID is kind of like trying to navigate a growing city using like a printed map from last year.
That is a great way to put it. But Claude uses what is called agentic search. It doesn't rely on a static index at all.
Okay, so how does it work then?
It actually operates locally on the live code base, just like a human developer would. It uses tools like grep to rapidly search through your raw text files.
Oh, so it's reading them and following references in real time.
Right. It's working from the exact reality of the code in that specific second.
Wow, it's like dropping a scout with a live GPS directly into the terrain.
That makes perfect sense.
Yeah.
But I mean, dropping a scout into the wild only works if they actually know the rules of survival.
Which brings us to what the sources call the harness.
The harness.
Okay, what is that?
Because Claude is exploring live terrain, you have to equip it with the right context. So the harness starts with healey.aea.md files.
And those give directory-specific instructions, right?
Exactly. So a cliety.md file in your database folder might say, always use the new V2 connection pool, never V1.
Oh, so the AI instantly knows the local conventions.
Right. And it avoids a critical mistake. And then you add LSP.
The language server protocol.
Yeah. Which means instead of just matching basic text strings, Claude gets symbol-level precision.
Okay, meaning it actually understands the code's logic and structure.
Exactly. It accurately traces how functions connect across entirely different files. And I assume teams can package all this into plugins, right?
Yeah.
So a new engineer on day one gets the exact same setup.
Yep. Good workflows don't just stay isolated as, tribal knowledge anymore.
Wait, let me push back here for a second, though. If we load Claude up with hundreds of clickoue.md files, custom tools, and plugins.
Sounds like a lot of data.
Yeah. Won't it just hit a memory limit? Like, how does it not drown in context before it even writes a single line of code?
Well, that's where skills come in. Skills are these reusable chunks of expertise, like a specific security review protocol.
Okay, but how does that actually help the memory issue?
They use progressive disclosure.
Mm.
The AI basically doesn't load everything into its working memory all at once.
Oh, I see. It only pulls that security skill into memory when it detects it's actually working on a security-related task.
Exactly. So the technical setup is highly efficient. But from our sources, even the best technical harness fails without the right human management behind it.
Right, which is a crucial point for you, the listener, especially if you are managing projects or teams right now.
Yeah. Successful deployments now require an agent manager or a directly responsible individual. You really need a human centralizing these conventions.
And they have to audit their AI configurations pretty often, right? Like every 3 to 6 months.
They do, yeah. Mostly because the AI models are evolving so rapidly.
But why exactly do old rules break new models?
Well, think of it like training wheels. An older, less capable AI model needed strict, step-by-step prompts to avoid making mistakes.
Right, that makes total sense.
But if you force a newer, highly capable model to follow those same rigid steps, you actually constrain its ability to solve problems creatively.
So the old training wheels prevent the new bike from going fast.
Exactly. Which means as AI becomes more autonomous, human governance actually becomes more important.
We are stepping up into these crucial management roles, really defining the guardrails.
Right. Which actually leaves me with a thought for you to mull over.
Go for it.
If AI tools are increasingly navigating and writing our code like human developers, will future massive code bases be designed primarily for AI readability rather than human readability?
Oh, wow. That is a fascinating concept to imagine. It is just such an inspiring time to be in tech.
It really is.
We are looking at a future of profound human-AI collaboration where we can tackle massive global engineering challenges together. If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.